everyone, welcome to the session of the program. In today's session, we'll be talking about the various architectural designs which we should be aware of in a sense. What are the services that are available from Amazon? How these services help us in building highly available, fault tolerant, and reliable systems. So, the objectives of this module is designing resilient architectures, which means how quickly can you recover from failures. So, failures do happen, so we have to anticipate for those failures and plan accordingly so that you can recover from failures pretty quickly and there is no impact to the application. Then with respect to designing multi-tier architectures, leverage multiple availability zones. Most of the managed services from AWS, they are spread across multiple availability zones. So that gives you a benefit in terms of your services are distributed across multiple AZs and hence become fault tolerant. Then designing performant architectures. So performance is another attribute that you want to look out for, wherein the services that you provision, you would like to have them performing. So moving on to the contents of today's session. So we see four areas. We want security. That is one of the integral aspects whenever you build applications on cloud platform. Security is of the concern. The second point that you would consider is performance. You expect performance from the resources that you provision. Are these services, in case of load, they are scalable enough? And when you don't need them, can they scale back in? Then they should be resilient, wherein you should be able to recover from failures as soon as possible. Then efficiency in infrastructure. So you should get the maximum value out of the resources that you have provisioned. So tools like Trusted Advisor help you in meeting all these requirements where the tool gives you a guidance in terms of all these four attributes. So in a well-architected network, you want to build your applications and deploy it on a regular basis. So unlike several years back, wherein deployments was not a very common affair, you had scheduled deployments once in a month or probably once in 3 months. The applications that what we see today, I've seen organizations going ahead with deployments multiple times a day. So you need to test your systems regularly, use automation tools to achieve that kind of level where you can regularly build and test your environments. Then, with respect to risks, understanding your risks is very important. And sometimes you need to accept the risk, sometimes you need to have a mitigation plan. Just in case of a risk, you have an appropriate plan to address for it. And then making informed decisions, determine the pros and cons of architectural decisions for performance and availability. Every design will have some pros and cons. So again, there could be various factors attributed to it. Most of the times I've seen cost is. So if you want to build highly available, but in that case, cost becomes a detrimental factor. If you recall that, the more you go on the availability side, the cost increases exponentially. So sometimes you know that this is a risk that I'm taking, but I'm willing to accept that risk. And then learn best practices. There are a lot of sample architectures available on Amazon portal for specific use case. And else we have seen various patterns during the course that you can leverage within your architectures. So the five pillars rather that we spoke about for a well-architected framework, you have resilience, high performance, efficiency, security, and excellence in operation. So we'll take each pillar one by one. So resilience is your ability to recover from a failure and adapt to changing conditions and then quickly regain the functionality. So from AWS perspective, again, they're a global player and they have footprint across 19 regions. They have multiple availability zones to increase the fault tolerance. So you always make sure that you design your applications with distributed workloads. So in terms of how do we measure the availability, these are standard industry recognized formulas wherein to calculate the availability, it is service availability minus the total sum of downtime. And then you have terms like MTBF, which is mean time between failures. So if there was a failure 6 months back and another failure occurred today, which means your mean time between failures is 6 months. You take an average out of it. So mean MTBF should be as long as possible. Then you have M terms like MTTR, which is mean time to repair. So this refers to what is the time that you take to recover from a outage situation. So this actually relates to what are your SLAs that your company or organization has committed to both external and internal customers. So resources typically in most commonly used application architectures that would help you provide high availability and handle failure. You have services like ELB, which is the implementation of load balancer. So load balancers, these are highly available. They can tolerate availability zone failures. So in the worst case scenario, a complete availability zone was to go down, your access to your application will not be impacted. Then you have services like auto scaling, again, can work both ways. You're running out of capacities or you want to scale down, auto scaling is the service that would help you. Then services like RDS, relational database services with multi-AZ deployments, you are at least guaranteed that even if to the extent if your primary database instance was to go down, your availability zone was to go down, your database services will still be available. And then you have Route 53, which is the DNS service. So not many understand the importance of DNS in the entire application architecture, where if the DNS service was to go down, your application, even though it's up and running, won't be accessible. So these are very highly available service that you should be incorporating in your architectures. So ELB, it is available at more of a regional service part of EC2 service portfolio. So anything that comes under EC2 is regional. So from examination perspective, we'll be tested on this, which services are regional and which are not. So you set up ELBs within VPC and you can move your instances from one environment to the other using ELBs. Then you have services like Route 53, which I spoke about. High availability is one aspect. It supports pretty complex algorithms, starting from simple routing to failover routing to geolocation to latency based. Specific to your location, you can choose either of the algorithms. Then RDS, again, you as a customer are taking the overheads of managing the database service. And then with respect to recoverability, as I spoke about, multi-AZ deployments, read replicas would come into play. Then auto scaling, again, to scale up or scale down based on your conditions that you have specified. So this is an architectural representation of a resilient architecture wherein within a region, there is no single point of failure. So Route 53, availability, manageability is Amazon's problem. ELB again is Amazon's problem, can tolerate availability zone failures. Your resources are spread across multiple availability zones or subnets. So even if to the extent availability zone was to go down, your application is still up and running. So likewise, the same logic can be applied to database services. Then with respect to implementing elasticity at the database layer, you can vertically scale the database services. So vertical here would mean changing or increasing the instance type, that is throwing more compute or memory or using a better storage option. Web servers, you can always go ahead for horizontal scaling, which is adding more resources. And auto scaling, we have seen, can add or remove instances based on the traffic patterns. Then from the storage perspective, we have seen a lot of storage options available within AWS. You have implementation of EBS, which is Elastic Block Storage. Within EBS, you have multiple options, general IOPS, provisioned IOPS, magnetic. So for database workloads that need dedicated performance, you'll always go in for provisioned IOPS. And for generic use cases, general IOPS works as a good fit. Magnetic is largely not used, but again, it is referred to as a cold storage. So again, the storage has been designed for specific use cases. So like for EBS, you use them with your compute or instances. Then you have implementation of object storage, which is S3 and Glacier. So S3, highly available, highly durable, can scale infinitely. So you as a customer really don't to bother about the storage and availability and durability of your content. Within S3, you have multiple storage classes. Standard is the default. Then you have RRS, infrequent access. So depending upon what your objective is availability and durability is the highest objective or cost is the objective, you will be selecting an appropriate storage class. Glacier, we know, specific solution for long time archival. Likewise, for handling big data workloads or manage data in warehouses, wherein you need storage in large quantities, make sure you select the right storage. So in those cases, you will be opting in for throughput-based storage options. And then with respect to backup options at every storage that we have discussed, there are options to and methods available to take backups and that help you in the event of a failure. So EBS I've spoken about, it is a network storage, persistent storage, and used at the compute instance level. Various types, general IOPS, provisioned IOPS, magnetic, and then throughput based. Then you have simple storage service, which is S3. you have Glacier, which is for long-term storage and archival. You have Elastic File System. So this is a network storage that you can assign to thousands of nodes. The storage can either scale up or shrink based on your storage needs. Then you have Storage Gateway. So Storage Gateway, if you recall, is an interface service that helps you extend cloud storage to your environments. And then Snowball, which is a data transport service that allows you to transport data from outside AWS to AWS and vice versa as well. So on how to make storage resilient, you have to choose for the right storage option. S3, availability and durability is the highest. For your databases, your multi-AZ implementation and using the replica servers makes the application highly available. Whereas DynamoDB is a fully managed service and uses schemaless data, which is highly available. Block storage again used with EC2 instance, and Glacier is for long-term purposes. Then try to create loosely coupled environments wherein one component of your application really doesn't know about the second component of the application. So in the event one component was to go down, you're still good. So decoupling would isolate the component of the system and eliminate internal dependencies. And these services are mainly used to create more resilient systems in case of failure of any component. So various advantages, you're ensuring highly available synchronous and asynchronous communication. You have data segregation, you get high throughput. And for synchronous communication, you have services like classic load balancer, application load balancers, and auto scaling. And for asynchronous, services like SQS, which is the messaging queue. Then you have SNS, which is simple notification service, and Kinesis being used for real-time data analytics. So for synchronous decoupling, it requires both sender and receiver to be always available. So in this case, traffic hitting your classic load balancer would only be sending the traffic to your instances if they are available. So we have seen in the demos that you can add and remove instances from your load balancers without disrupting the overall flow. For asynchronous services, even if since we are using a broker in between, which is a queue in this case, so the producer side really doesn't care whether the consumer side is available or not. So services like SQS, Kinesis, they are asynchronous services. Then multi-tier applications, depending upon your application logic, you can have a two-tier, three-tier, or n-tier application. And usually you'll have a presentation layer, a logic layer, which is the application layer and the database layer, and group the resources. Then for creating serverless multi-tier architectures, you can use services like API gateways, which allow you to securely connect mobile and web applications to business logic hosted on Lambda. So Lambda, we have seen that it's essentially your business logic that you put into a Lambda function, and Lambda function is triggered on need basis. It could be a trigger from your application, or it could be based out of an event that is generated by a service. So for serverless, again, VPCs will definitely come into play. So they will come into, I mean, for EC2 instances as well. But VPCs, give you logical separation in AWS and placement of resources, whether you want these services to be available over the internet or not. Accordingly, you will be placing them in public or private subnets. Then multi-tier applications, again, very similar to one of the architectural representations that we saw. A VPC would have both public and private subnetworks, which would be spread across multiple availability zones. Web servers generally go over into public subnets, app servers into private subnets. You can have external load balancers, internal load balancers. Then designing serverless multi-tier architectures from your mobile applications, you can use services like API gateway that would manage all the API calls for you and execute Lambda functions. So another important topic that we'll be discussing is disaster recovery. So it is about how do you prepare and recover from a disaster. So two important concepts in this disaster recovery, two terms that we should be familiar with. One is RTOs. So that is recovery time objective. So this is the time taken to recover from an outage. So let's say outage, we took 10 minutes to resolve an outage. So the RTO in this case was 10 minutes. And then you have terms like RPO, which is recovery point objective. So this is the amount of acceptable data loss measured in time. So for example, you are a banking institution. So what should be the RPO for a banking institution? Ideally, or for that matter, it has to be zero. You just cannot afford data loss of even 1 second. So you have to design your applications in such a way that depending upon the application that you are building and your organization commitment to your external and internal customers, you will be specifying both RTOs and RPOs. So both these RTOs and RPOs are based on the financial impact that the company would face when these systems are unavailable. So there are various methods that you can implement your DR plans. Again, eventually it boils down to what are the RTOs and RPOs your organization has committed. The simplest of all is backup and restore. So I, as a customer, I have very liberal RTOs and RPOs. I take periodic backups, let's say once in a day or twice in a day. And my strategy is backup and restore. So in the event of something happening to your primary services, what I'll do is I'll do a restore from the backups that I take on periodic basis. So RPOs in this case would be large. So a lot of companies do it. That's the simplest and the cheapest backup and DR plan that you are can implement. Then you have Pilot Light. So in the Pilot Light, what you're doing is with respect to data, you are consistently doing replication of your data from your primary site to your DR site, wherein in the case of outage, since the critical element is the data, you can spin up other resources on the fly and you're up and running in no time. Then you have warm standby. So warm standby would contain all the components of your application, but a scaled down version. So in the event primary goes down using either services like auto scaling, cloud formation, you can scale them up on an immediate basis. Then you have a multi-site deployment kind of a scenario. So in this case, this is like multi-region. So if something happens to one region, your application is still running out of the second region. And then lastly, AWS production to DR using multiple AWS regions. Again, this is like multi-site only, wherein you are leveraging multiple regions. You can set up your DR regions outside AWS as well. So if you recall, in one of the sessions we saw a slide wherein you could have a multi-provider or a multi-cloud provider for the highest level of availability. Then measures on how to improve the DR plan. Take regular backups after you have switched to your DR environment. So that's very important. We do take backups, but we actually never test them out. So in the event disaster happens, we're kind of struggling. So AWS gives you the access to perform inexpensive DR test without needing your DR infrastructure to be always on. So to test the DR scenario, you can write a script, one-time effort that you can test periodically, wherein you will get to know whether you'll be able to recover from a situation on a regular basis. Then monitoring and alerting is a integral aspect for every application. So use appropriate tools. You can use tools from AWS, which is CloudWatch, or you can extend your existing monitoring tools. And then automation is like the best thing that you can do to your applications, wherein tools like CloudFormation, OpsWork would help you build the environment on the fly. So since everything has been scripted and once tested, it would always give you the same result. Then with respect to performance and specifically about storage performance, couple of attributes that we should be looking at again: MTTR, MTTBF, mean time to recovery, mean time between failures, transactional processing workloads generally used with relational database services. Then IOPS is the key measure, input out operation per second, that your storage can support. Read write operations, what is the response time, and what is the amount of storage that is being consumed. So we know at the compute layer, we said EBS volumes are the ones that we should be using. And EBS in the background uses SSD backed volumes, which are essentially your data rather than being stored on magnetic tapes is being stored on flash drives. Then HDD backed volumes, these are used for large streaming workloads. Essentially, if you're using services like EMR or Kinesis. Provisioned IOPS, very important from examination perspective, is backed both provisioned and general IOPS. They are backed by SSDs, and this is the highest performance EBS storage available for critical IO intensive database and application workloads. So the maximum IOPS that you can provision is 32,000 IOPS per volume. With respect to improving the performance of your applications, you might introduce a caching layer. So rather than your request being sent to database every time, the most frequent access data, you can cache it in memory, and you can set up your own caching layer wherein you can build your own service or use services from Amazon. So typically used to handle hot data and reduce the load on backend. Then key characteristics of caching layer. One is persistent, how long the data would be persistent. What is the scalability attribute in terms of can you scale your caching layer? And thirdly, what type of data model key value store or a document store, what type of data model it supports. So ElastiCache is the caching service from Amazon, and that allows you to easily create and use caching clusters in the cloud. So you have both Memcached and Redis, which are open source algorithms that are available within ElastiCache. So Memcached is the simplest to implement and uses the in-memory key value store and is very high performing, but does not support advanced data sets. Likewise, the second algorithm, which is Redis, is durable, wherein supports the concept of replication, asynchronous replication, supports advanced data sets. So it's like setting up a mini database within memory. Then designing solutions for elasticity and scalability. Again, ELB comes into play, wherein sends the traffic to your healthy instances, auto scaling depending upon the thresholds that you have specified. And on scaling, ELB would be updating the DNS records internally of the load balancer. So the new resources have their respective IP addresses registered in DNS. So we spoke about two algorithms in the ELB. One was round robin and second one is sticky. So wherein if your session management is being done at the compute layer and you need to bind a user session to an instance, you'll be opting in for sticky sessions. Then which resources would use scaling plans? You have EC2 instances. We have already seen in the demo, you can use Spot instances. Then you have Amazon Aurora replicas. Aurora is homegrown AWS database service, relational and fully MySQL compatible. Likewise, DynamoDB can scale horizontally. So as a user perspective, you don't care about the scaling. And then you have ECS tasks. ECS is the container service wherein it can scale up like your compute resources. Thank you.